Hey, Math 098, we are continuing section 3 of chapter 10, and we are, I guess, just looking at conics, and we're solving systems. So looking at substitution, we've done substitution like this earlier in the year where we had a system, and remember, a system is just two or more equations, and in this case we just have two because we have two variables. And it's up to you which variable you want to solve for. It just makes sense because y is already by itself, that you can rewrite the second equation. And notice I'm just taking out that y in that second equation and replacing y with what y is equal to, which is the square root of x. And the reason why that is all you need to do to get started on this problem is you can cancel out the square root and the square undo each other. And now we have this quadratic, and it may seem like a long time ago, but to solve a quadratic equation, we can just set the equation equal to 0. This is actually really nice because it's factorable. Factors of -6 that add to be 1 are 3 minus 2. I don't know if I should scroll down. I'll just scroll down. So we're looking at x plus 3, x minus 2, is equal to 0. And so the zero product property would tell us, you probably remember the shortcut, x could be -3 or x could be +2. But let's think for a second. Don't just turn into a robot and stop right there. Is if I went back to the original problem and plugged in -3 in for x, we cannot square root -3. So this is, we're back to an extraneous solution. Now you might be sitting there and saying, well, what if I asked you to put imaginary numbers on here? Let's ignore imaginary because, yeah, you could have an imaginary. And the reason why I want to ignore imaginary is I want to use a graph. And I'll talk about that here in a second. So what do I need to say is that x equals 2 is the only possible answer. But remember, we need to think of this as an ordered pair, an x and a y value. So if x is 2, then plugging 2 in for x, then y must equal the square root of 2 is the only answer that works. So what does this even mean? Well, if I go to Desmos, as I said, I want you to be able to graph this. And remember, Desmos does non-functions. And maybe I should even emphasize that this is a circle, which is why we're doing this in the conic section part of the assignment. Yeah, so if I were to just type in those two equations, y equals, I got to find it somewhere in here. The square root button is like right here. And then x squared plus y squared equals 6. And there's only one point of intersection. Now the downside to Desmos is, for whatever reason, it doesn't give you exact values. So x is 2. And if you were to type in the square root of 2, you can see that's where that other value came from. So I'll know if you use Desmos if you don't leave your answer in simplest radical form like I expect to see. And notice there's no other values because the other answer that would have worked would have been imaginary. So that's all we need. So as I, feel free to hit pause or write down any questions and bring them to class. But as I move to the next page with the next exercise, notice that it's asking you to check the solution with the graphing calculator. And for our purposes, we're going to use Desmos. Because this might be, well, this one's actually a function, so it's okay. But again, I want you to practice using substitution so you get to choose which variable do you want to solve for. Now, most people are so used to solving for y, and it's actually easier to solve the bottom equation for y. You could solve the top equation, but you'd be subtracting x squared and dividing by -4. That's why that's a little bit faster. So I can take that into the top equation. So notice all I'm doing is I'm rewriting the top equation with removing y from that top equation. and replacing with what's equal to y, which is negative x minus 1. So as I distribute that in there, maybe I'll change colors again. It turns into plus 4x. That would be plus 4 is equal to 0. Is equal to 4. I'm getting ahead of myself, because if we're solving a quadratic, we have to set it equal to 0, which is subtracting the 4 over. That's kind of nice. So that cancels. And this is factorable. It might seem like a long time ago when we factored, but this is just a greatest common factor. I'm going to write that out, GCF. And that greatest common factor is they both of these terms share an x. So I can greatest common factor an x out of that. And then by the zero product property, we can say that x is equal to 0 or x is equal to negative 4. So now it actually makes sense that both of these answers work. Because if x is 0, we could get an answer for y. If x is 0, we could get an answer for y. Same thing if x is negative 4, we can get an answer for y. So instead of putting a box around this, I'm going to take this value for x and plug it in right here, and just think about negative 0 minus 1. That would tell me that y equals negative 1. So it's very important that you recognize that it's an ordered pair, that when x is 0, y is negative 1, that you don't just say the answers for y are this, and the answers for x are this and this, because it's only answers for y, negative 1, when x is 0. So it's very important that you write it as an ordered pair. I hope that made sense. But if it didn't, feel free to write down your question and ask me, and bring it to class. So again, I'm plugging in negative 4 in for x. Well, the negative of negative 4 is positive 4. Minus 1 would give me y equals 3. So it's really important that you write it as an ordered pair. When x is negative 4, I got a y value of positive 3. So this time we do get 2 answers. And as always, I'm going to show you with Desmos. So I'll just start over. X squared minus 4y equals 4, and then x plus y equals negative 1. And as you look at the graph, I can just click on the points of intersection. There's 2 points of intersection, and they both work. So those are both correct answers. Just a warning to you that you could come across a system where you have no solution. For instance, if I made that like negative 5, they never cross each other. So there are times that you have 2 answers, 1 answer, 0 answers. So this is the situation where we had 2 answers. And be ready for extraneous solutions as well. I guess I should warn you about that. So here's another one that, again, I'm asking you to use substitution. Just as a heads up, this top equation is a circle, and this bottom equation is just a line. So if you went straight to Desmos, you might see an answer right away. But I've been showing you how to solve this using substitution. And I want to point out that you can use substitution for solving for a different variable, like x. And the reason why I'm bringing this to your attention is it might be easier for some of you to add y to the right side instead of solving for y. So the reason why I'm bringing that to your attention is you can do that as well into the top equation and replace the x with y plus 5 squared plus y squared is equal to 9. I hope all of that made sense. Just be careful. Make sure that you FOIL this out as you solve. Okay, so it's y squared. The outside term would be plus 5y. The inside term would be plus 5y. That would be 10y. And 5 squared is 25. I don't know if I really need to explain that. You guys are good at that, where y plus 5 squared means y plus 5 times y plus 5. That's how I got that middle term. So this is a quadratic. And I want to set it equal to 0, so I'm going to subtract 9 over here. And just a reminder, it might make sense to you to do the greatest common factor. I'm just going to move over here. I'm talking about bringing a 2 in front. Whoops. 10 divided by 2 would be 5. And 16 divided by 2 would be 8. Well, as I'm looking at that, I don't know if we have any factors of 8 that add to be 5. So what that tells me is that we might want to use a quadratic formula. I know it's typically x equals, but we're going to do y equals because that's the variable that we have. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And again, this 2 is now factored out. Just think about it like if you divided that 2 over, it's no longer there. 0 divided by 2 is still 0. So that's where I got my a value is 1, my b value is 5, my c value is 8. And if you notice under that radical, I have 25 minus 32, which means we're going to have the imaginary answer, if my math is right, is the square root of 7. So what that means is there's no possible values. There's no solution to get this. So this is actually the example I warned you about. If you looked at x squared plus y squared equals 9, and then x minus y equals 5, these two things never cross. So there's no solution. And that is possible. So just kind of a warning for you. There might be a situation, though, where maybe there's 1, 2 answers. I was trying to make a tangent line, but it doesn't look like that's happening here. But the situation that we have has no solution. And that's all we can deduce, is that there's no solution in this system. I'm not going to ask you to leave your answers with imaginary. Just leave it as no solution, and we're fine. And maybe for the sake of time, I do want to show you this one, and then you'll be ready for the homework. Is you could use substitution and solve for a squared term. So for instance, if I did this problem this way, I would just add y squared over. So what I'm saying is I can replace an entire squared term with what it's equal to. So x squared that I just circled is equal to y squared plus 1. And leave everything else alone. Maybe I'll even switch back to that black color. 4y squared equals 16. So as I solve this, I can subtract 1 over, and I can combine like terms. I have 5y squared is equal to 15. So y squared will equal, if I divide 5 over, 3. And just don't forget, when you square root, you do get two answers, a plus and a minus square root of 3. Now, if I were going back to solve, I wouldn't put in plus or minus root 3 in right here. I would just go back and I would plug in 3 in for y squared. So that means that x squared would equal 3 plus 1, which is 4. So that means x is equal to plus or minus square root of 4 is exactly 2. Now, you might be sitting there and say, well, what are the ordered pairs? That's a great question. And let me point out that there's actually 4 ordered pairs. So if we looked at that x squared plus y squared, 4y squared equals 16, we have an ellipse. And then x squared minus y squared equals 1. You can see that we have 4 ordered pairs. We have 4 points of intersection for the ellipse and the hyperbola. And hopefully that made perfect sense to get ready for your homework, which you are now prepared for.